Hey guys, today we will learn about a little bit about the synchronous generator, about V curve, how we draw it. Okay. Later we will learn about synchronous generator, so don't worry about it. Just today is focusing on what is that like about reactive power, like over excited or under excited, you know what I mean. So let's see here first. Uh, there's a first of all, the generator, it's a make it electricity, right? So there's two part, you know. First part is revolving armature, like this picture, or this picture is a revolving field type. Like as you can see, second part is we mostly use, and then this is just a magnet is, uh, revolving. So okay, I'll explain, guys. So first of all, we need to learn it here. Look at that here. You can see here this part. This is it's a connected prime mover. You know what I mean? So this part we say rotor, rotor, and then it's connected to the with the slip ring and brushy. You know what I mean? And then DC, DC. Yeah. You know what I mean? So IF is here. Field current. Sorry. Field current is here. We controlled the reactive power as I explained from here, rotor part, right? And this part, it make it generate electricity, you know what I mean? Sine wave. So that is the general part. And this prime mover, we say turbine, right? So actually it's getting from mechanical power. Like it could be hydraulic or wind, geothermal, you know what I mean? Like that mechanical power makes it the prime movers or turbine, you know what I mean? The rotated. You got it. Yeah, that is a general thing, yeah. And then later we will I will make a more lecture about those, so don't worry about it. So except some specific, situation or just like in the lecture, generally they explain more, look at the, easily to understand. We we saw many times this, but actually in the field we use a revolving field type. Yeah, that's it. And then here, so so what I wanna say is here's the excitator, right part. Yeah, here. Here's a DC, right? So it's controlled uh, magnetic field. You know what I mean? Field current. It's a controller, right? So depending on the this value, the flux's values is a change, right? This is we say load current because it's connected to load here. So we wanna know this induced, voltage. So the result is this. Later, by the way, later we will learn, okay? Just the result is the E's magnitude is 4.44, N is N, F, and pi F. So this is the ton. How many tons? It's the wiring. How many tons it's winding, and this F is frequency, hertz. And this is, as you can see here, this part, flux, right? But actually it depends on the IF, field current. So it's actually controlled by the exciter, right? So I wanna say is when you make the generator, it already fixed here. Fixed the tone and frequency is 50 or 60 hertz. It already fixed, right? So only the E, the magnitude is controlled by depending on the this. You know what I mean? So actually about this part, the P, no, the frequency. Frequency part is it's a related to prime mover, right? How fast it is the rotor, the rotors, rotating. But this time I want to explain about focusing on reactive power. You know what I mean? So that's why I mentioned this. Let's see, guys. Okay. And then here, this is equivalent circuit. We have to draw it. We have to know how to draw it. First of all, now you don't need to. But first, I wanna say is here. This is amateur reaction. Later we will learn. Okay, don't worry about it. Because amateur reaction, it depends on the load. If it's inductive or if it's capacitive, the load, it's the amateur's flux is flexible. It could be increase or decrease. Later we will learn. Okay, and this is the lines resistor, and this is leakage inductance. So mostly this part is this part is mostly taking about the resistor. You know what I mean? In the circuit, like a 99.90% is value is here. The amateur reaction, this part is big. You know what I mean? So we could draw it in the equivalent circuit like this. JX. Then like this. Because compared to these two values, this is mostly it takes about the magnitude. You know what I mean? So what I wanna say is here. So we need to make it equivalent. We need to first of all need to could draw the equivalent circuit, right? Then we could make an equation, right? So for example, here is E. So E equal. So I said mostly this part we have it the most of values. So I will say this is just JX. So E equal. This is here, right? V equal I, because the current is a series, right? Current I J X. This is we make it the equation. So this V is our reference point. So V 0 here. Look at that. So here, if I draw it here, V 0 here, right? And then our general situation is we using the load, right? So our current is kind of lagging, right? And then I said J is 90 degrees make it precede, right? So from here, 90 degrees precede is here. So I multiply JX course here. This is our general situation, in the power system. I wanted to say is, but now you don't need to memorize. Just try to be familiar how I draw it and what is our general power system situation. Yeah. And then okay. So as I already said, the is magnitude is 4.44 and n f f uh, uh, sorry pi f, right? So this part is I said it's controlled by the if, right? The excitation from excitation part, right? So today we will learn about the first of all overexcited and then underexcited. Overexcited means I gives you more like being a more supplier, to supply more powers, reactive powers, right? So let's see. First of all, uh, you guys need to see is this yellow line. You guys can see here. This means I make it the output is P is constant. You know what I mean? Constant. So that's why I make it here, this part. So first of all, I said power factor is first of all, PF is 1, like 100%. So look at that here. And this black line, you guys can see. If it's I is here, this I is load current. You know what I mean? Load current in the equivalent circuit, right? So I said J is 90%, 90 degrees more precede, right? So if I is here, 90 degrees here, right? So here 90 degree. So I make it here. And this is when your power factor is 1. But we want to know increase the IF, right? So if we, so which means we want to more give us more powers, right, to the load, right? So P is, I said, constant here, you guys can see. So if you guys see here, if I increase E, this green line you can see, you don't need to see this I current right now, but it has just just because it's a constantly the output is constant, same limitation. But we wanna see we wanna increase this E because we increase the IF. IF is related pi F, right? So which means if we increase this, the induced voltage is also increased, right? So it's increased, right? But look at that. If it's increased, V is the same. This is a reference, right? We already made the equation. E equal E is equal V plus I J I X, right? So this is a reference, our output, right? So look at that. If it's I is if it's E induced E is increased, what happened from here? The I, the voltage drop. This part we say voltage drop, right? So this drop is makes more higher. You know what I mean? The magnitude is the loss is getting bigger. You know what I mean? So look at that. 90% if we sorry, this is not 90. So I said J is 90 degrees, precede, right? So I is here now. So what happened? So the I load is more magnitude is more bigger, right? More longer, which means more bigger values, right? So we can see that from this page, what we know is if we increase, you know, IF, excited current, we make it is induced is voltages more bigger, right? And then the I load current is also gonna be more longer. We can see that here, right? And let's see. I wanna explain is this part. So before I explained I is at first time. This is a cosine. This is a sine. So at first time I is here, right? But since we overexcited, what happened? The I is here, right? As you can see here. So which means it added sine, reactive current, right? So we could now know that, oh, it added this sine side, the reactive part of us current as it increased, right? When we increase the excited current, we can see that, right? So let's just first, before we move to the underexcited part of page, what happened? So look at that. So E equal N F and pi F, right? Pi F is I F, right? So if it's increase, decrease, also E gotta be decrease. We could expect, right? So let's see with this expectation, what happened? So this is under exciting part. Okay. First of all, first part is when your power factor is 1 here, right? Here, this part, the black part. So equation is E equal V plus J I X, right? So we wanna decrease IF equal pi F, right? What happened? Let's see. So we now know is expected is E is in decreased, right? So let's see. If we E move to here, the E's magnitude is this, you guys can see from this line and from this line, black line E and the green line E. The length means more length is more have a more bigger magnitude. It means so we reduce the burst E, right? So what happened? So V is always reference point, same here, right? So we wanna know is now E is here, right? But look at that here. JIX is I said the voltage drop, right? So we need to make it triangle. What happened? Here is 90 degree, right? So I said J is 90 degrees, make it precede, right? So I is here, 90 degrees, here, this part. So what I wanna, actually I is now here, but it depends on how you see the page here. So if I is here, 90 degrees actually here, but I wanna not that you make guys confused. So here, 90 degrees, here. So what I wanted to say you guys is here is I said I is load current, right? Load current. If it's load current, what the value is here, what? This length. What happened? here or here, this part. The load current is increased, right? Even we decrease IF, exciting current, we decrease, but actually E is also decreased. So for example, what happened here is, look at that. So if I reduce I, E is, for example, here, E, here, I will draw E is here. So E is here, better this, and voltage drop is here, right? So look at that. So E is here, 90 degrees here. So I gotta be here, I load here. You guys can see that. So which means even I mean the induced voltage is the value is reduced, but load current is increased, right? So this situation, what happened is the generator is absorb the reactive power from the line. This is happened like at night time. You know what I mean? Daytime we need more and more of power demand, right? Use lots of equipment, right? Motors or whatever. But at nighttime we generally sleep mostly, right? Compared to the daytime. So load demand is it's a decreased. You know what I mean? So this is that situation. We say under excitation. Just absorb the reactive power from the line. So look at that. What happened? This is so actually from here when it started, the I is here, cosine is I is here, right? But here now sine is this part. So we added the reactive current, but this time is leading under exciting, right? But over exciting, it was here, cosine here, lagging. That's the differences. In the lagging current, we supply the reactive power. But in the leading current, we observe, you know what I mean? Observe the reactive powers from the line. That's it. So so this is the result, guys. Today is kind of difficult, but don't worry about it, okay? So we will learn. So under and over excitation. Over means we are supplying, right? Supply. So actually, IF is increased, which means E is increased, right? And then same result is I load is also increased, right? So this is IF, we say, this part. So IF is increased and IL is also increased here, IL, I load. And here, under excited, we reduced the IF, which means E is also reduced. We observe reactive power, right? E is also reduced, but I load is increased. So we will draw this V curve. This is what we learned. And this part, stability limit, because of excitation, we will later learn about it. Because of under, excitation situation, because of that, there's, the end of part, end of link part, there's, yeah, saturations happen. So we will learn later, okay? Don't worry about it. Yes, today's lecture is done. Thanks, guys.